Yeah, welcome everybody at the Aerial Robotics Community Working Group meeting. Today is January 31st, Wednesday. And this meeting is the scientific/presentation meeting, which means is that we usually invite somebody to give a presentation about the project, anything related to aerial robotics. It can be ROS, doesn't have to be ROS, but yeah, like of course it's kind of up to them. But just kind of like to widen our how you say our interest, let's say, or like information knowledge. And today that's actually me. But before I actually will present about our projects at the Crazyflie, with Crazyflie at Bitcraze, I'm first going to do a couple of announcements first. And after that, I'm just in conclusion of the meetings and just some regular ROS meeting business. So just a couple of announcements. I'm going to be at FOSDEM this weekend. So we're going to have a open source robotics bird of a feather that we're going to organize there. So I don't know if anybody of this group is actually going to join FOSDEM. It's in Brussels, Belgium. So I also, on this course, I've also opened up kind of a call for participation. So where people can indicate their interest of forming a subcommittee, or if they would like to give a presentation. I have the link to the form. I can quickly add it to the chat right here. Hey, Ramon. Nice to see you.
Hi,
so yeah.
nice seeing you.
So if anybody would like to participate with this working group and wants to contribute something to that, then please fill in this form and I will try to kind of match people up with the same interests. That's the idea, if there's enough, of course. Also, I would like to let you guys know that Aerostack is presenting at the Gazebo meeting today about their simulation work. So that's actually in about 2 hours. I'm going to join. So if you guys are low on meetings today, there's a nice meeting to join. And also, I think what was also interesting is that I saw that there was going to be a one-time only meeting about mocap standardization in ROS. If anybody's doing like indoor flight and using mocap quite a lot, perhaps it would be good to join that to indicate what should be standardized in ROS topic messages for mocap systems. Also quite important for aerial robotics. All right. So with further ado, it's my turn to give a presentation. So I'll just open up a different tab. There you go. If you're able to see anything. All right, I think you're able to see the new slides. So I've been let's say part of this working group for a while, or at least initiate at least the meetings for that. But I've actually never really given a presentation during the presentation scientific meetings. So it's kind of also kind of an introduction to the company that I work for, the platform that we actually make. And I also want to use this opportunity to show you guys, or even demo your guys, spoiler alert, the Lighthouse positioning system, which is kind of an indoor positioning system for drones, but it can also be used for robotics in general. Just wanted to kind of see what the interest is, because we might also want to demo this during ROSCON this year, because it's very close to nearby us. Odense is just 2 hours from us. So yeah, Bitcraze AB, that's the company that I work for. So we actually make the Crazyflie quadcopter. It's a really tiny quadcopter. You can see it right here. You will see it flying at one point as well. And we kind of consider ourselves to be mainly a hardware development platform company, but we do also maintain the open source firmware, the open source software that runs on the computer to work with the Crazyflie. And we're currently located in Malmö, Sweden. So currently at 4 p.m. in the afternoon. And we're now at 5 members of the team, which is Tobias, Marcus, and Arnaud. Those are the 3 founders of the company. Then you have Barbara and me, Kimberly. We're actually going to be having 2 new team members soon in the coming months, so that will be exciting. Kind of a history of Bitcraze. It started about yeah, I think 14 years ago, it's kind of like a hobby project, which these three guys actually did next to their consulting job. That project became so popular that that they actually started the company in 2011, which started with the Crazyflie 1, which was really used by hobbyists at that time and hackers. And now I think also from like since 7 years ago, we already have the updated version of Crazyflie 2.1 and like 0 and 1. So, and who uses the Crazyflie? Yeah, it's like before it was mostly hobbyists, let's say, especially in the Crazyflie 1 era. Nowadays, there's a lot of university researchers that use the platform. We also had quite some people that use it for like indoor show designers as well, and educators and their students, of course, that they buy a couple of these Crazyflies for Lodeck, for instance, and they use them to kind of learn control theory, robotics courses, and etc. etc. So that's kind of like an idea of who uses this small platform. All right, so I'm going to kind of dig into the Crazyflie itself, but like it's not the quadcopters, of course, not the only thing that we kind of maintain. We maintain kind of a whole ecosystem around it as well. So here's kind of like a short overview of that. You have, of course, the quadcopter, which is the Crazyflie, of course. We also have a couple of options for positioning systems as well. Either that has been developed outside of Bitcraze that we support, or that we actually have developed in-house. And of course, communication is also very important. That that we have like at least one computer is able to communicate with the Crazyflies at the same time as well. So I'll just explain about that. But first, let's go into the quadcopter. So the Crazyflie hardware, I already showed it to you. It's very small. There's 4 DC coreless motors. So it's of course like less strong and brushless, more efficient though, and safe. This is I don't need to wear, like, I'm wearing glasses, but I don't need to wear safety glasses or like anything of like a protection when one of these hit me. So it's like the frame of it is actually fully like the PCB board. So it has kind of a motor mounts, and then of course like the motors right here. It's like 24 grams. Of course, can be a bit heavier dependent on what kind of hardware is on there. But at least like with one cell LiPo battery, it has about 7 minutes flight time, which we always warn people not to deplete the battery because LiPo batteries don't deplete them. So we have 2 microprocessors on the Crazyflie. One is an STM32F4, and we have an NRF51, which is more of like the communication microprocessor. And it has like, a very basic also an inertial measurement unit for gyroscope and accelerometers that we then later use for let's say the position estimation. Well, not that for the position estimation, but at least for that attitude estimation. Yes. Oh, I already saw a question indeed, like, can you run ROS on it? I think like ours is already explained indeed that we have ROS 1 and ROS 2 support. It's mostly community driven, but we do help them out quite a lot. There's also a micro ROS examples for the Crazyflie as well, if you're ever interested. I think ePersima, they provide some Crazyflie micro ROS examples as well. Back to the hardware. So this is kind of like an overview of what's happening. Like the STM32F4 is where the main autopilot runs on. It's also kind of the one who drives the motors directly. The IMU is of course connected to that. But I think mostly important is that it also runs with expansion decks, which means is that you can add more sensors to it, or more capabilities, or more processing capabilities by these expansion decks that you can add to the Crazyflie itself. Let's see if I have an example somewhere. No, I don't. I thought oh, there you go. Like I already have like one expansion deck on here. I'm not going to take it off because I want to fly with it at one point. But you, for instance, can also, for instance, add this expansion deck, which is the flow deck. It has an optical flow sensor and a range sensor. And this is actually the Lighthouse deck. But we also have like kind of a LiDAR deck that has a ranger that's pointing in 4 directions. You can do some simple mapping with that. And yeah, we also have a couple of decks that are meant for positioning that I'll explain in a minute. So first of all, like very quickly on communication. So we have like in-house, we mostly have like, of course, like the firmware itself is C-based, but we have a lot of like client software that is Python. So we have a client and then we have also a Python backend for that. We also have mobile clients, although to be really fair, is that those are not really well maintained. They still work, but we're actually thinking about dropping them soon. But we actually are able to communicate with the Crazyflie by using the, let's say, yeah, how do you call it? Like the Crazy Radio PA. And then we have, let's say, our own, made also in-house our own protocol. It's called the Crazy Radio Real-Time Protocol, or Crazyflie Real-Time Protocol is here to be. Yeah, but for instance, like people from MicroROS have performance inputs, use that as kind of a wrapper for their, for their protocols as well. So it's pretty much all open source, so people can change as they like. Going back to ROS 1, because this is of course the community working group for ROS. So there is ROS 1 support that is through what we kind of call Crazyswarm 1, which was supported by the University of Southern California, by James Price and Wolfgang Hoenig, where they were able to, a couple of years ago, fly 49 Crazyflies at the same time. And at one point, I would like to give a presentation also to go more deeper into that. Unfortunately, I didn't really have the right time to prepare. But they used ROS also because it was easier to maintain swarms in that sense. Like our client's only able to support one drone at a time. Like you're able to make swarming scripts with our Python library, but that is, so that is a little bit more work in terms of they have to build up the management itself, and ROS already has it kind of embedded. I actually gave a presentation about Crazyswarm 2 and the ROS 2 support for the Crazyflie, which we are kind of helping out Wolfgang Hoenig, who is now at TU Berlin. In terms of maintaining that. I'm not really going to go into that much. I can give a presentation later that I can kind of give the overview or the update. But a year and a half ago, I actually gave a presentation at ROSCON here. So I would definitely recommend you checking that out if you haven't, to know a little bit more about the work that we've done for that. So I will just refer that later. So the communication, like I said, Crazy Radio Real-Time Protocol. So it has a couple of you can give an address to the Crazyflie communication speed and channel and a median, so you can add more Crazy Radios as well. And of course, if you have multiple Crazyflies, you should probably change the address and channel, let's say, for better communication. That's just kind of the tips that we give. But you're able to use one Crazy Radio for multiple Crazyflies. Let's see what are at the time. Perfect. So I actually, what I mostly wanted to focus on this presentation was positioning. As I said before, there are multiple positioning types that the Crazyflie ecosystem or the Bitcraze ecosystem supports. First of all, is motion capture systems. That uses markers to reflect back the infrared light that these cameras shine off, so they're able to capture that and interpolate to a position. We also have something called a local positioning system, which is ultra wideband based. There was a show video that I showed in the very first slide. I don't know if you remember that, but that was also using ultra wideband as well. The Lighthouse system is actually a system that is based on SteamVR by Valve. Which they use for virtual reality for positioning of their headsets. So I'm definitely going to explain a little bit more about that later. And of course, relative positioning with the flow deck, which is not a global positioning system, but this is kind of a relative positioning system. With the flow deck is mostly used for STEM education and research, so that people can just fly at home. with very little effort. So yeah, the Lighthouse positioning system. It's actually, yeah, we think it's really cool. And we were able to kind of like reverse engineer it. Like one of my colleagues saw this technology at like one hacker fest, I think, by Valve, like a really long time ago, and came with the idea to actually use it for positioning for the Crazyflie itself. And it's kind of based on the Lighthouse positioning stations V2, so like the Steam VR base stations 2.0s by Valve, and virtual reality gaming. You can see me here in action with a headset, and I'm being tracked, or at least the headset is able to track itself by means of whatever comes out of these base stations. So I'll be able to kind of like explain to you a little bit more how they work. So yeah, the mechanics of these Lighthouse base stations. So there is a GIF here, so it kind of shows what's happening. So it's not the same as a mocap camera. A mocap camera emits infrared light, but it also needs to receive infrared light back from reflective markers. So this is not the same principle. It only sweeps infrared light planes, but let's say the one who receives it has to do all the processing itself, let's say. So it has like a rotating drum, and we have like one of these like base stations that we opened up as well, and it kind of like rotates like this, and then the thing happens like is shown in this GIF. I think the GIF kind of explains it all already. So it has a field of view of horizontally 150 degrees and vertically 110 degrees. It has a range of about 6 meters. It has, like I said, a single drum with 2 tilted beams, about 30 degrees from the center. And they run at about 50 hertz. However, they're able to run at slightly different frequencies, let's say. Like, they have options for different channels. So that means is that there's about like 16 channels that are possible. So that means is that you're able to have 16 base stations in the same room, let's say, if you have hardware that's able to receive those. So the Lighthouse deck that's on this Crazyflie that has like 4 sensors right here. And once one of those sweeps hits the Lighthouse sensor on the deck, it kind of records a timestamp, and there's also data decoded that's encoded in the sweep, which means it's like the start of the revolution of the drum. The base station identification, like I said, there's about like 16 channels that these base stations can be set on. So it's able to kind of identify that. And also it's able to send through calibration data as well. So that's pretty cool. So how do you actually do position estimation on that? I'm assuming that you guys already know a bit about state estimation. There's different methods that you can kind of do position estimation based on these base stations and the light, like the sweep that is being received on these Lighthouse decks. Like you can kind of take the 2 sweeps and calculate the ray to the sensors and kind of like do that from one base station to another. It's kind of the crossing beam method, we call it. But the EKF measurement model that we've implemented is perhaps a little bit more refined, let's say. And of course, like on board, the position is being calculated on board of the Crazyflie, so it's like on board of the STM processor. So so like the base station, it emits those sweep angles, and then together with the geometry of the base stations, they're able to kind of like put that through a sweep angle measurement model. You can also kind of like do that the same for the yaw. Not yet full pose, but then that's like, those transferred measurements, let's say, that's used then in the EKF together with the IMU to calculate full pose. So the IMU is able to also kind of do the roll and pitch in there as well. Like technically you could, like theoretically you could calculate full pose on it, but until now we've only implemented yaw estimation, just to let you know. So I've also added some documentation here as well. So if I share the slides later, you can just go and double check all the calculations that I showed to you. But I didn't want to kind of show that too much in this presentation right now. So yeah, so this is the measurement model. Bit of mathematics. I'm not going to go too much into that, but yeah. So this is the measurement model that's being used in the EKF, and it uses the position of the base station that's being stored on the Crazyflie itself, so it's able to use that information and is able to kind of like defer, let's say, calculate the angle based on that. So I was also talking about a bit of the geometry estimation. We have implemented a type of geometry estimation that looks a little bit like how you would calibrate, or not calibrate, I mean, estimate the geometry in mocap systems. So you would put the Crazyflie in let's say, in the center of the coordinate system, and then at one point you would like wave it around and collect all kinds of data, similar to how you would perhaps do geometry estimation on a mocap system. But yeah, this is done, of course, like not exactly the same, but it works quite nicely. But it's quite important to know where the base stations are. That is very crucial information to make them fly. Yeah, so like currently at this moment, it's possible for the Lighthouse deck to detect 4 base stations at the same time, which means is that at least for a long time we had a flight area by 10 by 10 by 3 meters. We should not have sunlight, very similar to mocap system, and very little reflections. I do have to say, with the sunlight, I have flown today with the window open, so it's maybe not that bad, I would say. Yeah, I think it's time for demo. Let me just put the Crazy Radio in. And I have a Crazyflie right here. And let me just see if I can kind of show you guys where I have base stations. Like I have a base station right here. I'm just going to stop presenting so that's clear to see. So I have a base station right here and also one over there. So I have 2 in this room. And I've already done the dance of the geometry estimation before. So I'm going to spare you that exciting part of it. So I'm just going to connect to the Crazyflie. Like I can show you guys the client, but it's maybe nice. I thought it was more nice for you guys to actually see how well it's able to fly. So I'm just going to make it take off so that you're able to kind of like see it. Okay, I don't know if you're able to hear something. Let's see, are you able to see it? I'm not sure if you're able to see it. It's very small.
Yeah, I can see it.
Okay, so it's here. So it's as you can see, it's pretty stable. Like, you know, it's sometimes losing like a touch of some of the base stations, but it's flying quite well. It's like if we would say, like, you know, it probably has millimeter precision in terms of position, like getting for the position estimation, which is pretty much on par of a mocap. But yeah, so it's definitely better than if you would use an ultra wideband system.
Hey Kim, we have a question.
Yeah, sure.
Someone raised their hand.
Yeah, go for it.
Maybe it was a mistake. They raised their hand.
Okay, we can we can handle questions later. But at least, like, you know, it's flying, it's doing stuff, and I should probably make it land. But I just want to show you what happens if, of course, I put my hand over here and it won't be able to detect anything from the base station anymore. Which is actually pretty difficult. It's able to. I really have to have a box around it almost. Here you go. There you go. Now it's drifting. Now it's drifting. I'm actually pretty good. It's able to fly pretty long without space station. But yeah. So, yay, demo. Take that, demo attack. Oh yeah. Luckily, I'm not flying a swarm. That would have been a little bit different. But next time, if I give a presentation about Crazy Swarm 2, then that's going to be the case.
I have a question
Yeah, sure.
if you don't mind. So, for currently, you are using your Python library, or is it using ROS or one or two?
So this is currently using our Python library, but I can do
Okay.
exactly the same thing with our the Crazy Swarm 2 project as well. Because
Uh-huh.
the positioning is pretty much done on board, so the only thing that I would give it to it is like a position set point, let's say, like I'm doing right now. And also we're using also the same backend, or like one of the backends is also exactly our Python library as well on that project. So it's not that much of a difference, to be honest. But
Yeah, because for ROS one, like for now, we are using ROS one with the Crazyflies, and
Mhm.
it's been quite difficult to take off with mocap.
Yeah, yeah, it's like
They're literally
it can
crazy.
work. It can work at ROS one because, like I said, it's like positioning is done on board, so that's completely unrelated to ROS one or ROS
Yeah.
two. So yeah, yeah, I'm going to talk about like differences between mocap and the other
Okay.
positioning systems later. But we think this is kind of like the Lighthouse system is our positioning system of choice for demos
Yeah.
because it's so easy to set up. Um, yeah, I'll just make a land.
Okay.
So do not deplete the battery, they say. So somebody raised their hands.
Yeah, hi Kimberly, this is Srijani.
Hi.
Did you mention that this lighthouse was developed in-house, like by Crazyflie, or is it some like external vendor?
So yeah, so the base station by itself, the Lighthouse base stations, that actually was developed by Valve, which is the gaming company, which also
Okay.
does like a lot of their virtual reality hardware, let's say. But we kind of did all the firmware changes on the Crazyflie that was able to read out those sweeps and was
Mm-hmm.
able to actually translate that to an onboard positioning. So that is the things that we've all implemented. And also like for instance like the geometry estimation way is also something that we've also developed in-house. The base station itself, the ones that are here, we haven't manufactured those. Those are
Okay, got it, got it.
by Valve. Yeah.
Yeah, because I asked this because we tried to use the HTC Vive setup, and it comes with a Vive ROS package. For us, it was not very accurate in terms of
Mhm.
ground truth. Of course, we had other localization mechanisms that was just for ground truth benchmarking, but we couldn't get it to work very reliably. So I was just like seeking your opinion on that, and also like what would you say are ideal positions for these lighthouse base stations, in a space of 10 cross 10 or 20 cross 20? How densely would you place them? How far across from each other would you place them? And is there a criteria that you use to determine that or something?
Like we don't really have a very strong rule to set these up. Let me just put those. Well, it's like as long as it's about flying a half a meter underneath these space stations, it's fine. Also, like the current, and I will tell that later. The current limitation of this current Lighthouse deck is that's only able to process 4 base stations at the same time. So in that sense, to make most of your flight space, it would be handier to spread them out as much as possible. Like if in our current area, or at least like what we had before was a 10 by 10 by 3, then we would just either put them in the corner or in the middle, let's say. So of the box. And I think that the higher the better, as long as it's not too high that you come if that is past those 5 like the 6 meter range. Yeah. So but we have a couple of tips to set the base station up on our documentation on the website, also in the tutorial. So But I would say like I'm not sure that I know like if the HTC 5 ROS package. I'm not sure like exactly how that works. Like we definitely do things differently, and we also do things quite differently to I don't know if you know Lip Survive. They also have support for Lighthouse system as well, and they use completely different algorithms too.
Yeah, I think the ViveROS package uses that library underneath.
Yeah, it's we have now like we have also looked at that at one point, but we actually our implementation is very different. Our EKF measurement model is very different as well. So it's actually like I think it's our and also the geometry estimation is also very important, because if one of the base station is not estimated at the right position, then that will also completely put the positioning off as well. So those are kind of like improvements that I think not at least when we compared it back in the day, like our positioning now is better. But it's like onboard the Crazyflie, so you still need to transfer it back to the computer in case you want to have a note. But I'll just continue, and then if there's any more questions, I will refer to those in the back.
Yeah, thank you.
Yes. Let's see. So the current limitations of what I was saying before, like per software wise, or like firmware wise, I must say, it's like we only have XYZ position and yaw estimation, but theoretically, it should be possible to do full pause. We just haven't implemented that yet. And hardware wise, the Lighthouse deck is only able to handle 4 base stations at the same time, which is like 2 sweeps per base station. So 8 sweeps per second. Yeah, so at 40 hertz, so that's already quite a lot. So that is a bit of a limitation, let's say. And also there's not really a lot of pre-processing possible on the chip that's currently on the Lighthouse deck. Before I continue, I just want to kind of give an overview of like comparing this positioning system to other positioning systems. Like I said, like Lighthouse positioning is also infrared based, just like mocap. It's an a much easier setup than if you compare it to mocap, but although like local positioning with ultra wideband is also quite easy to set up, to be honest. Also, Lighthouse positioning, it has millimeter precision, like to the point that mocap is not precise enough to really determine how precise it is. So if anybody knows a better positioning system to really determine a good ground truth, let us know. And compared to the local positioning system that's ultra wideband is more centimeter precision. And the price is also very important, because these base stations of Valve, they're about now, I think, $200 per piece, let's say. You can and you can use the base station also that they sell. It's like there's nothing different to the ones that we use here. And mocap cameras are definitely a lot more expensive per piece, let's say. So it's definitely a very better price-wise, but the local positioning system is also quite good price-wise. And also, like I said before, like the onboard positioning is done. The positioning is done fully on board of the Crazyflie firmware, while with mocap system you always need to have an external computer to determine the position and then communicate it back to whatever vehicle you're using, which can be a bit of pain if you're using very, very large swarms. But that is also kind of like, but also to be fair, like for the local positioning system with ultra wideband, it's also onboard positioning as well. So recently we have a new office, or not like a new addition to the office. So we have added like 110 square meters to our current office, so more flight space. So obviously we needed to make a very good use of it. So that's why we actually in the last half year we really made a lot of improvements in terms of prototyping. So like we were working on Lighthouse V2 with improved processing, which means it's actually able to handle the sweeps of 16 base stations at the time, which is a lot. Like 16 base stations times 2 times each at 50 hertz per so that's 50 rotations per second. That's a lot. So we tried to fly in an area of 2 by 9 by 3. So, but we've placed them pretty high, pretty close to each other. Like it's not as efficiently spread, all of the 16 base stations. And also we're working on the standalone Lighthouse positioning node as well. So perhaps we would like to hear your feedback about that. So I have here, we always do a Christmas video for our special demo. So that's what we did for this one. Let me see if I can run this. Yeah, so I didn't turn on. So you can here see all the base stations being placed. So we had about 16 in total. And there's also a couple of other things. Oh yeah, that's also nice that we're working on that I haven't presented yet, but this is also a prototype of a brushless version of the Crazyflie. We showed a lot of things in this Christmas demo. We always want to do too much. And then it's actually going to fly around the Christmas tree in the flight area, all using the Lighthouse positioning system. So, yeah. So yeah, it's a pretty big flight space using that. So that's pretty nice. So that is kind of what I have for now. So like these are all kind of current developments, but what I'm really hoping for is that the Lighthouse V2 deck and like perhaps also the standalone node that I was talking about. Yeah, that is actually something that we can present at ROSCON when we're going to be there, because we're definitely going to be there with a demo booth, flying 9 Crazyflies with the Lighthouse system, with the new Lighthouse V2 deck. Please hope. But yeah, that's our plan. So I hope that people will be interested in that. Let's see. So here's like a couple of links from the website, and also like where we set the support and the emails as well. And yeah, I think now it's also time for any follow-up questions, if you have any. Yes, go for it, Khaled.
Really good work, guys. It's quite amazing. I somehow I'm a little bit surprised of how close it is to what we are working on right now. But it is really good work. I think I gave you a call, Kim, last week, but I didn't know that you are the Kim that I'm talking to. So.
Oh yeah, it's good. It could be like. Are you from
Egypt?
No. I think that was probably my colleague.
Yeah. Maybe then it is your colleague.
Yeah.
But really good work. A lot of open questions, which makes things more exciting. So well done, and let's keep up the good work, and let's keep thinking together, and maybe you never know what happened in the future. But really good work. I just have one question regarding the localization with the beam thing. Are you sure that it is safe for a human, that it doesn't affect any of your eyes or something like that?
Well, I've been working in this environment with a lot of base stations for a long time, so I haven't seen any problems so far. In terms of it's safe, like this is not a product that we actually have developed.
Totally.
Yeah, but I do think that's like at least the documentation of Valve have shown that they have tested this, like with at least like with human eyesight, but we cannot really
confirm.
We're not the representatives of the ones who make these base stations.
It just came to my mind because in some of the systems that I used to work in, maybe I used to work a little bit in LiDAR systems, so that was one of the questions that was required. But keep up the good work. Let's keep thinking. Let's keep kind of working it out together, and let's see how it works.
Yeah. All right. Thank you. Banana, what you had a question?
Yeah, thank you so much for this nice talk and the awesome demo as well. I was wondering, have you observed any drift over time in terms of the position estimates?
No, not really. That happens very rarely. If there's any, if there's any drift, like if you don't have any yaw estimation, it would probably be the yaw at one point. But it's also kind of like then it really has to fly for a long time, which
Yeah.
7 minutes is usually not really enough. But since we do yaw estimation, that's hardly ever happens. I think drift will only happen if it loses connection with both base stations. Like it always have to see at least one in order to do position estimation. It can also sometimes happen that if it takes off, that maybe the deck is not mounted on properly. And then, of course, it doesn't get any signals anymore. Or if like one of the sensors get damaged, then that's also an issue. But those are kind of like the only reason why it should drift at one point. But luckily, we have an LED on this deck. So if it actually loses, if it doesn't detect any sweeps, you will actually get an orange LED instead of a green LED. So then you know the difference. For the exception of if your base station geometry was not estimated properly, so like they're completely on the wrong positions, then you would still see a green LED, but then, for instance, like then the position doesn't converge. So then you would need to kind of like check out the position first before you fly. But if everything is working, I have pretty much never seen any drift happening if it's receiving the position from if it's receiving sweeps from the base station. That is, no, never.
Oh, that's awesome.
Yeah. Is there anybody else that have any more questions?
Yeah, Kim, I asked a question in the chat. So what are the max speeds that you have flown one of these at? Just curious.
Ooh, very good question. Yeah, there is at one point, because I think especially for the yaw estimation, there are some assumptions being made and that you need to have received this, both sweeps at relatively the same position. So that is the only, I guess, like the limitation for that. Like the actuals. So I guess like the fastest we've gone, it was from the video that you just saw, I would say. I don't know how fast it is, but that's very fast because that is with brushless motors. So a regular Crazyflie cannot even handle that, and that was still able to fly. So yeah, I would need to double check that. I will come back to you with that. But I think there is at one point a limitation of how fast you can actually go with this positioning system.
Okay, cool.
Yeah, I will try to update the thread or update it on Discord, like our Discord channel, or like on the discourse thread once I have acquired that information. Yeah, Samuel, go for it.
So hi, I'm Samuel. I'm from Singapore, and so yeah, I'm curious for the case of if you have two different rooms set up with 4 base stations each, can you move the Crazyflie from one to another? Like if the base stations don't interfere with each other, can it transition across? Yeah.
Yeah, it really depends on how far they are away. It should definitely be possible to do that. We actually, a few years ago, we have done a demo where we actually combined the Lighthouse positioning with the flow deck and also even the ultra-wideband based local positioning system, where we had the Lighthouse system here and halfway on the way to the flight lab and in the flight lab itself. So there was like quite a lot of space between the Lighthouse places. But of course, the position of the lighthouses, you need to, so like they have to also be synced up as well. So like, this is then position 0, but the one in the flight lab needs to be that position 20 meters or something like that. So that is something that needs to be synced up. And of course, if you're going to fly in between these rooms and there's too much no sweep angle detection, then it might be handier to also have a flow deck in between to at least make it not drift too much. But I would say, like, you saw like what I was doing here during the demo, that I was really closing it off. I think like if you lose the sweep angles for just a few seconds, or maybe even longer than that, it's able to handle that quite well. So yeah, but we haven't so that's kind of the experience that we had, but it should definitely be possible. And if it's not possible, then you add a flow deck, so it can kind of fly in between, let's say.
Yeah, cool. Thanks for the answer. Yeah.
You're welcome. Are there any more questions?
Did you find that the accuracy improved with more of these lighthouse stations? Because in the Christmas video, I think you said there was 16.
Yeah.
And it looked pretty accurate going around the tree.
Yeah, I guess like because of course the tree also, and this is some occlusion of some of those. So if you have occlusion in your space, that's handy, of course, to have a couple more. Of course, the Christmas video was done with the Lighthouse for version 2 deck, so that I was able to handle 16 base stations at the same time. But if you have a room without any like obstacles in there to occlude it, I would say that's like 2 already is a very good. You already have a very good estimate. Adding 3 or 4 doesn't really improve it and just makes it more robust against occlusion. But yeah, 2 over just 1 base station is definitely better, like a better option, because then you have like more distance between where the sweep angles are coming from and from 1 base station. And yeah, like the way that the sensor positioned apart, there's going to be a little bit more inaccurate. The position is going to be a little bit more inaccurate because it just needs to handle these really small angles, and then you have very high chance of its noise still going into the positioning estimate. But yeah, I would say 2 is already good. 2 is already good enough for a clear flight area, unoccluded flight area. And yeah, and after that's done, yeah, it's the more the better. I don't know. Though yeah, that's what I forgot to also mention, is that if you have a lot as well, then you have the problem, of course, of the drums are rotating all at a different frequency. But if the sweep angles are coming at the same time on the sensor, then that is of course data loss. So the more base stations you have, the more chance you have of that happening. So that's also something to keep in mind. But I don't have any specific numbers. I hope that answers the question.
Yeah. I was thinking there's probably an optimal number of base stations. At some point, it can be a disadvantage to add more, I think.
Yeah. So yeah, exactly. So, but I think like at one point we do have to make some measurements for that. But let me just continue to 2 other people from Alex. Alexis, you had a question?
Hi, hello. Thank you for your presentation. It was really interesting. And I have to say that I already work with SteamVR as well for drones. And I feel that it works really well if you are trying to do, for example, proof of concept situations on that kind of stuff. But I'm kind of curious about how you are using that attachment that you place on the on top of the drone. I saw some people that they use the actual Steam VR marker, but you are using a in-house solution. How did you come up with that? That will be the question.
Yeah, like basically I think these sensors are similar sensors to what the Steam VR marker is using, actually, but you don't see them directly because there's a nice casing over it. But these are very, very similar, like light sensors that they use as well. Yeah, but except for like we don't have it all over the node. We just have them on a plane, which is, yeah, perhaps, yeah, like, you know, there are limitations of what you can of course measure with that, and there's of course you have to assume that you have to play the flat plane as well, and yeah, if you have the base stations here and you're holding the Crazyflie like here, then it's not able to detect the sweep angle very correctly. So that's why then you would need another base station. But yeah, so that is kind of like the that's actually where those sensors come from.
Okay, yeah, because I was also like trying to understand what those limitations will be. Mostly because the how can I say, the exotic shape that those Steam VR markers have probably are the reason behind why they are like that, right? To avoid those plane limitations. Um, okay, but do you have any issues about, like, I don't know how to say, like identifying the target that you are tracking?
Yeah, the thing is that you don't need an ID bit per target, because each target is able to determine its own position.
Okay, gotcha.
So it's not like mocap at all that you need to, like, you know, you have to have a unique like, you know, marker set. The thing is that the item that's receiving those sweep angles is the Crazyflie and the Crazyflie alone. So it's able to determine its own position on there, which means is that, yeah, if you have a swarm, each of them are just determining their own position, as long as they, of course, like have a yeah, they do have to have their geometry of each of the base stations shared, like, you know, in their shared memory that is all based on the same coordinate system, of course. But yeah, that's kind of like basically you don't need an ID.
Interesting. Well, thank you.
Yeah, you're welcome. Rafi, just one question before I can close things off for the meeting today.
Yeah, Kim, it was a great presentation. Thanks for giving us a insight on all these things. So, Kim, one thing is that I just wanted to understand the path planning part of this, right? So, are you doing any ROS-based path planning or anything like that on the hardware as such?
Yeah, so like on the hardware itself, like this was just me giving a let's say a position set point that I get, like when I showed it, and so that didn't have any ROS included, and we have controllers on the Crazyflie firmware itself, so it was doing that all by itself. Given that's the Crazy Swarm 1 and 2 project, they do more with trajectory control. So I hope to like present it at one point also as well. And they actually also do a lot with like uploading the trajectory on board of the Crazyflie, so that you don't have to communicate every single step along the way, because it's like, you know, that's kind of annoying in terms of swarming, let's say. I'm not sure how far the micro ROS people are in terms of trajectory control on board with ROS. I don't think so that they have something like that, but yeah.
The local planners and the global planners, right? So I guess the local planners are kind of okay, but when it comes to a global planner, it is quite a bit of a challenge, I guess. So locally,
yeah, I think so. Yeah.
Yeah, so we are trying to get some ideas around it. So yeah.
Yeah, it's like what is mostly being done on board is like position control and simple trajectory control, but not yet based on any output. Let's say it's definitely not based on any of the nav2 trajectory controllers, but you are able to send the velocity command. So if you do the trajectory control of the local and global planners off board, and you send it the command, like the velocity commands to the Crazyflie, then it should be able to handle that. But yeah, but it's kind of like a whole discussion of how much you want to put on board and off board. Like, you know, a lot of things are possible within the confines of the STM.
That's right.
If it's okay, I would need to. I'm going to kind of close off. So let me just share the meeting slides again. So I will, of course, like all the slides that I've showed you so far, I'm going to share on the Discourse thread, or so that will all be presented to you. Yeah. So yeah, next meeting is a developer meeting. So like I said, like fill in the form for participation. I shared the link in the chat already. So like the setup that I proposed last time is that first announcements, then the subcommittees that we have, we don't have a lot yet. We'll present like, what's work done, what are their plans, and also I'm going to, before the meeting begins, I'm going to ask from the subcommittees what the important discussions are. So yeah, so preparation for the current committees, which is currently only 3D outdoor planning. Are there any important discussion points, any important PRs? Just let me know. And of course, for those that want to participate, fill in the form so I can start connecting people with each other. Did anybody had a question? Just a very quick one before I.
It was just a quick question about the committees, but maybe let's see when we talk next in 2 weeks or something.
Yeah, I think like if you have any specific questions, I would definitely recommend you to join the next one. But you can also look at the recording of last meeting where I explained quite a lot of things of what we.
I did, and I was super interested in the indoor because this is what we're working on.
Okay.
Yeah. So
yeah, then you should fill in the form. It's not so the form.
I did as we speak today.
Ah, perfect. Yeah. No,
But
like the
please
form
confirm if it is not complete. So maybe
yeah.
I did submit, but when I don't know, maybe double check after me. But let's see how it works.
Oh yeah, no worries. It's just to kind of like have some kind of indication of how like what the interest is, let's say.
No problem.
So there it's not binding whatsoever. It's just to kind of like see what people
I just have a few questions about how the workflow of the subcommittees, but maybe let's save these comments next week for.
I think that's a good idea.
Yeah.
So they're not next week, but in 2 weeks, 14th of February.
Exactly.
It's actually Valentine's Day. So
I see.
So yeah, everybody that's joining is very lonely, like including me. No, I'm even married, so it's like just have to disappoint my husband. So Valentine's Day. So the link for the GitHub organization for the working group is also like github.com, this ROS Aerial. We have the community pages there, the subcommittee landing pages, and also the meeting notes as well. And and of course, like if you want to do a presentation, say it in the forum or email me or Ramon. And that's it. Thanks you guys for joining. I will stop the recording now, and I will see you guys in